This is Narendra Kumar, and today we'll do this wonderful book, NCERT India, Intermediate First Year Chemistry, or we can say 11th class chemistry. 11th class, actually, it's advanced chemistry, I would say. 11th class chemistry. And the first chapter is atomic structure. Let's start right away. Each video will keep it 5 to 6 minutes only. We'll enjoy each video nicely. Let it go for as long as it wants, as many videos as it wants, because we will enjoy the process like a song. Every 5 minutes, there'll be a song of chemistry. Chemistry first year, 11th class. Intermediate first year, it's called in India, in Andhra Pradesh. Chapter 1, atomic structure. The heading, there is one kind of a quotation. The rich diversity, the rich diversity of chemical behavior, rich diversity of chemical behavior of different elements can be traced to the differences in the internal structure of atoms of those elements. You understand? Rich diversity of chemical behavior of different elements can be traced to the differences in the internal structure of atoms of these elements. Now he starts the chapter. Introduction. The existence of atoms has been proposed since the time of early Indian and Greek philosophers, 400 BC, long back, who were of the view that atoms are the fundamental building blocks of matter. According to them, the continued subdivisions of matter. According to them, the continued subdivisions, you go on cutting, subdivisions of matter would ultimately yield atoms which would not be further divisible. Okay, the word atom has been derived from the Greek word atomio, which means uncuttable. Finally, that is uncuttable. That's very interesting, no? The root or non-divisible. These earlier ideas, which means uncuttable or non-divisible, these earlier ideas were mere speculations. These earlier ideas were mere speculations. Like, imagine, maybe it's like that, with a certain kind of intuition. And there was no way to test them experimentally, but you have to test them, no, you have to see them as they are. These ideas remain dormant, which means inside, not active, for a very long time, and were revived again, revived, they came back again by scientists in the 19th century. The atomic theory of matter was first proposed on a firm scientific basis by John Dalton, a British school teacher in 1808. His theory, called Dalton's atomic theory, regarded the atom as the ultimate particle of matter. In this chapter, we start with the experimental observations made by scientists towards the end of the 19th and beginning of the 20th century. Experimental observations. These established that atoms can be further divided into subatomic particles, that is, electrons, protons, and neutrons, a concept very different from that of Dalton. The major problems before the scientists at that time were, what are the major problems at that time? One, to account for the stability of atom after the discovery of subatomic particles. Now, once the subatomic particles are discovered, they want to know how is the atom stable. I would like to remind that the chapter is atomic structure. So the first problem was to account for the stability of atom after the discovery of subatomic particle. Second, to compare the behavior of one element from other in terms of both physical and chemical properties. How to compare two elements. Three, to explain the formation of different kinds of molecules by the combination of different atoms. How to explain that? They wanted to know the structure of atom to explain all these things. And four, to understand the origin and nature of the characteristics of electromagnetic radiation absorbed or emitted by atoms. And this is the introduction. This is what they try to answer, and they have gone very deep into the finding. Now it's come to a stage where it's fascinating, and lot of it is a mystery still. That doesn't mean it's some vague thing which many people unnecessarily relate like that. There is some deeper thing going on there. Science is still progressing, but this is the progression. First, Dalton came indirectly a real conclusion with clear cut experimental facts of definite proportions. We have done that in the 10th standard. Then they found out electron, proton, neutron, and they wanted to know, I repeat, to account for the stability of atom after discovery of subatomic particles. How are atoms stable? Second, to compare the behavior of the element from other in terms of physical and chemical properties, to compare with physical and chemical properties. Third, to explain the formation of different molecules by the combination of different atoms, to explain that how why those molecules are being formed, and finally to understand the origin and nature of the characteristics of electromagnetic radiation absorbed or emitted by atoms. These are the four things which will answer. Actually, we'll answer. Okay, so we'll find out how the electron was discovered. We'll find out how the proton was discovered, how the neutron was discovered, what are the atomic models, and slowly we'll come to the current state of what scientists believe only. It's not fully, they're fully sure, but which kind of theories and all. Finally, I'm saying believe only because there will be many questions you might have in your mind. Scientists also don't know the answers to that. I'm telling this now itself. I tell in the class also. Because obviously, like you, I come and say there is a wave and there's a particle. You'll innocently ask, sir, but it should be one of the things. Then we have to understand that these phenomenon which has been discovered, they have not been hypothesized or explained fully today by the physicists, including Feynman. Feynman himself says, I don't know. That doesn't mean I cannot know. It doesn't mean some crazy thing is happening. We don't know. Like there are many things we don't know. No, we don't know so many things. That way, they say we don't know. Nobody knows. They are saying actually as of now. So maybe you should go ahead, and I believe you can, and the future generations will bring about a greater clarity. I also get intuitions. This could have been done. There is a certain kind of confusion in physicists also. They're also human beings. There is a certain tradition of philosophy. There's a link between philosophy and physics. These things you must know first beforehand only, I believe. Otherwise, you'll keep asking the answer and thinking that somebody knows the answer, not realizing that nobody knows the answer. You know? It's quite a heartbreak and a headbreak when you realize that. But then that's the word. And slowly you'll get used to the fact that there are certain, you'll get it. It's not that scientists don't know. They don't. They, if you read them, they will tell openly. This we know, this we don't know, this is my intuition. That's why they keep differing, really. That is a fascinating part, also, in a way. But that's the fact, also. We have to face that fact that that's how it is. Once this is clear, this is the first introduction, first video, so I'm making this very clear. Then everything is easy sailing because what scientists have discovered, definitely you can also discover. You can rise to their level. You can be really a very good scientist. It is just due to lack of education that people are not becoming scientists. Thank you.